In this question, we are given with two particles P and Q, and these are the two particles P and Q of masses 0.6 kg and 0.2 kg are attached to the end of a light and extensible string which passes over a smooth bed. The particles are held at rest with the string taut. Both particles are at a height of 0.9 meters from the ground. The system is released and each of the particles moves vertically. Find the acceleration of the point P and tension in the string before P reaches the ground. And the second part, we need to find out the time taken for P to reach the ground. Now, in the first part, we will be finding the acceleration of P and the tension in the string. Now, first of all, we need to figure it out that what are the different forces which are acting at the point P or on the particle P. So, this is the force of gravity or its weight acting downward and tension in the upward direction. And here is the net force. Now the net force, since the particle is moving, particle P is moving downward because its weight is bigger than the weight of the Q. So it will move downward. So the net force will be W minus T is equal to, according to Newton's second law of motion, is equal to mA. Now W is mg minus T is equal to mA. So what is m? Mass of the particle P is 0.6 multiplied by the value G is 10 minus T is equal to again 0.6 A. So this becomes 6 minus T is equal to 0.6 A. This is equation number 1. Now we will find out the forces which are acting at the point Q. So this is our point Q. Now the force here we have got two forces which are acting at the point Q. The first force is again in the downward direction, is W, and tension in the string there will be in this direction, that is in the upward direction. Now since the particle Q will move in the upward direction because it is lighter than the point Q, so therefore the net force in this case will be equal to P minus W is equal to mA according to Newton's second law of motion. And again T minus W is mg is equal to mA, and T minus m, and that is the m of Q is 0.2 into 10 is equal to 0.2 A, and T is equal to T minus 2 is equal to 0.2 A. And this is equation number 2. Now by solving these two equations, that is equation number 1 and equation number 2, we can able to find out the value of the acceleration. So let's solve these two equations. 6 minus T is equal to 0.6 A, and T minus 2 is equal to 0.2 A. So simultaneously solve these two equations. Now this T is cancelled with this T, and we are left with 6 minus 2 is equal to 4, and this will become 0.8 A. And from this we can find out A is equal to 5 meters per second square. Now you can put this value of t in any one of the two equations and you will find out the value of t. And when you will put the value of a in equation number 1 or in equation number 2, you will get t equal to 3 Newton. So this is our solution of the first part. In the first part, we were asked to find out the acceleration and the tension in the string. So this was our first part. Now the second part. Now the second part is, here is our second part. We are required to find out the time taken for P to reach the ground. Now we know that P is moving downward in this direction, and the height of both P and Q from the ground level is 0.9. So initially, as we are given in the question that initially both are at rest. So P is at rest, therefore its velocity is 0. And is the distance covered by the point P of the particle P. So this is 0.9. After this it will hit the ground. So the distance multiplied s is 0.9. Now we have already found out that the acceleration is 5 meters per second square. So we will be using this data in order to calculate the unknown value here. This is the time taken. So we will be using s is equal to ut plus 1 over 2 at square. So u is 0. If this becomes 0, we are left with 1 over 2 at square. And also we put the value of s, which is given as 0.9. So it is 0.9, and you can write this as at square is equal to 0.9 into 2, or t square is equal to 0.9 into 2 divided by a, and the value of a is, we have already figured it out. This solved it in the first part, and it is 5. So this is 0.9 multiplied by 2 and divided by 5. So when you simplify this equation, you will find out that t square will be equal to 0.36, and by taking the scale on both the sides, you will get t is equal to 0.6 seconds. So this is the value of